Actually, we do a lot of civil works starting from dam, canal, then potable sewage mains, aqueducts, pumping stations, reservoirs, and also water tank and swimming pools. So what we do in structural repair basically, so we are into mainly we do high pressure water. With this, using this instrument, we clean the complete concrete actually, and also we do breakout of small concrete, reinforcement protection, then surface preparation, then we do the crack injection, impermeable coatings, and also performance of concrete. So these are all our prime activities what we do in the structures. So this is on structural strengthening. So the important elements what we carry over is, it's a new technology, dry shotcrete. Normally we do wet shotcreting in most of the project, but we are introducing a dry shotcrete with different needs actually. And also we do the application of carbon fiber reinforcement and jacking of dams. So heavy elements could be jacked in the dams, like we do the precasting of elements outside, and that could be jacked using the hydraulic equipments, and it could be fitted onto the jacks in dams. And also we do the underpinning works. And in upgrading of concrete structure, so what we do normally is we do the precasting of large elements outside the dam, and also we can do the pre-stressing works, that is for external pre-stressing, or sometimes it can be a ground anchor, so just to increase the strength into the concrete. And this technique could be used even to increase the crest height of the dam. So this is one of the speciality, and we use hydraulic jacks to handle the precast elements. So you can see here we got a frame here, and using this frame, this element is precast outside, and this is being lowered. And also we can do replacing access bridges, replacing of spillway gates, and assembling erection of fuse gates. So we have, moreover, in the world, we have globally done more than 30 dams all around the globe. So we have a good level of experience in various aspects. So this is one of the important credential of Fresnel, where we do the anchoring works. So using this technique, we can increase the height of the dam. So even for Narmada Dam, this can be one potential techniques to increase the height. So here what we do is basically this helps us to increase the dam stability and also to increase in the crest height. And here the drilling is the very major concern, where we have to maintain accuracy of 0.5. So the equipments what we are going to use, it matters a lot actually. And also fabrication of this corrosion protection, since there may be some leakages, since it is in the water structure, so we have to give some emphasis on the anti-corrosion measures actually. This is very, very important. And also we can do this ground anchor even up to 2,300 tons capacity, each individual anchor. So it's a huge anchor, it requires big machineries to handle. So this is one of the important technique which can be adopted when we wanted to increase the height of the dam. And we have more than 30 dams within 10 years duration we have done, with a vast experience in different fields. And here mostly we wanted to emphasize on dry shotcrete technique. So this is on masonry dam, where first we prepare the masonry dam using our hydro demolition machine. We got a very specialized machine which works with water actually, high injection of water. This prepares the surface using water. So at around 2000 bar pressure, we can pump in the water and clean the surface, so that it gives this rough surface, so that over that we can install the reinforcement, and over this we apply the dry shotcrete. So dry shotcrete we can prepare up to M60 or M70 strength, so greater strength. So this is one of the thing. And so in this strengthening, so we can just apply some tie rods also for holding arrangements and waterproofing since we apply. And this is one of the dam in France, strengthening of concrete with dry shotcrete. So extensively Fresnel uses this dry shotcrete because of its strength, and also because of its monolithic structure. Because when we apply this dry shotcrete into the existing structure, it becomes a good binding, and also it acts like a monolithic structure. So we have proven this in several tests. And these are all some resins under a controlled environment. It is important to work with resins under controlled temperature and also under controlled environment. And these are all some dams, so waterproofing membranes. And this is one interesting dams which we did. We have cut all these elements and it has been replaced. So here we have cut all the concrete structures and it has been replaced with the dry shotcrete. So again, dry shotcrete have been used. So under controlled temperature, and again this is same project. And here this is for repointing of masonry and resins with or without coffer dam. So these canals could be lined with this technique. And these are all some jobs, canal jobs which we did. And for here we do some kind of additional pre-stressing, the external of the structure, and also waterproofing. And this is one of the good, again for dry shotcrete, it's a different technique inside the tunnel. The tunnel was earlier like this, then we used our frame system, and first we made a rough finish, and we made this dry shotcrete concrete. Yeah, oh sorry. And this is one of the project which we did in Bhutan. So here again inside the tunnel we can do some kind of anchoring for strengthening purpose. So it can be vertical upward anchoring. So this is one of the very critical technique to use, vertical upward anchoring with the combination of nails and also anchors actually. And this is prefabrication. And again focus on dry shotcrete. What is the difference between mainly on wet shotcrete and dry shotcrete? So here wet shotcrete actually we add water before spraying, and also there is a possibility of poor adherence. We need to use some kind of accelerating admixtures, and the pumping speed is low. So the bonding is not as efficient as dry shotcrete. So in dry shotcrete, we have a high spraying energy and also high speed. So here if you see the bonding between the original member and the applied shotcrete is very high. So the bonding is high and it acts as a monolithic structure. This has been proved in various tests.
Your time is up. I would request you to kindly...
Yeah, I will just shortly conclude. So this is on dry shotcrete. So this is a very wonderful technique. Here we bring to the table mainly 2 or 3 techniques. One is dry shotcrete. The second one is ground anchoring, and also for hydro demolition technique. But there are various options. We can do it, but this is one of the options to improve the technique, and also we can do the combination of pre-stressing as well as ground anchor to improve the structure. So these are all some jobs which Fresnay have done. This is one of the interesting job between France and...
I think I would request you to kindly conclude because we are running short of time.
Okay, thank you so much. If there is any information you may need additionally, we are at stall number 27. We can discuss in detail. Thank you so much.
Thank you. Thank you very much for the... Now we have Trimble for their sponsors presentation. Within 10 minutes time, because we actually started a little late, so we are running a little late, but then I feel that we will end up sacrificing the time, so I would request you to kindly conclude within the time.
Mike, please.
Yummy? Good. Okay, I represent Trimble Monitoring Solutions. It's a division of the company called Trimble, which is a international company that specializes in measurement techniques. I'm going to give you a very high-level overview of the product that we have and that we've been applying to the DRIP project for the number of years to date. The business area that we operate in is called the Monitoring Solutions business area. It's a dedicated group of people who specialize in the monitoring of structures. The product that we have is called Trimble 40 Control, and it is basically a dam safety monitoring solution. It is a piece of software that is designed to measure the performance and the behavior of a dam. It works as follows. We start with the dam, which is one of the structures we're going to be monitoring here in the drip project. So we start with the dam, and we take the existing sensors which are on the dam already. Now all of the dams that we've looked at in the drip project so far have got sensors on them in various forms. We take those sensors, we get them operational. If necessary, we replace them. If necessary, we just upgrade them. We can add new sensors to the dam. The typical sensors that we use here are GPS-based sensors, optical-based sensors, and seismic-based sensors, as well as data level components which then are connected to geotechnical sensors. So we take the existing sensors, we take the new sensors, we acquire the data from those, and we feed them into a software package. The software package has a SQL database in it, which is an open source database. The numeric processing that takes place in the background processes the data from the sensors, converts it into a data time stream, and feeds it into the database. The information which is in that database is then available for analysis and for alarming and for reporting through various forms. So you can have it on your desktop, your laptop, tablet, cell phone, etc. This is the overview of the basic system that we have. So we concentrate on measuring the performance of the dam. We can multiply this outwards, so we can take a number of dams. So we'll have a single system there, another dam, third dam, and we feed that information into a centralized control center. So this allows us then to have the performance of the dam monitored from both local locations as well as from a control center. This control center facility also has an ability to summarize the performance of the dams in a particular area. We use icons to show this. We have a single icon, for instance, showing here the performance of a single particular dam, and the color of the icon indicates whether there's any form of problems which are taking place on that dam. Selection of that particular icon will then allow you to go into the performance information related to that particular structure. Now you can connect virtually any sensor to the dam, to this system. I've listed a whole lot of sensors there where I'm telling you can have a look at them. But essentially you can measure any performance parameter on the dam, around the dam, inside the dam, behind the dam, related to the dam. If it can be measured, we can capture that data and we can then process it. There's one piece of equipment which I'd like to specify or I'd like to concentrate on a little bit here. And this is a new piece of equipment which has been released during the past couple of months. It is a combination of a seismic sensor and a GPS sensor, and it allows us to measure the performance of a dam under seismic conditions, both microseismic and large seismic activity. And the sensor allows us to determine with almost instantaneously the effect of a seismic action on the dam. This is a unique piece of equipment. There's no other equipment like this worldwide. It was in fact released here in India for the first time and is currently being deployed around the world. We have an example of it here, and our recommendations is to put it on all of the dams in the drip project area, seeing that India is a seismically prone zone. Information that we get is available via a web interface. We've concentrated specifically on creating a web interface with our target market being a semi-technical person. So we've really relied on intuitive actions on this web interface. It has full functionality on it, all the functionality that you would expect for an analysis program. I'll just touch on it briefly here so we have a short presentation time. We obviously can chart. Now the most important thing about this charting capabilities on this web interface is that we can use Boolean comparators and we can compare data from completely different... Okay, this thing's now done its thing. It's gone on strike. It's run out of time. Fix it if you can. You can. This is why we don't do a live demonstration with installations. It's waiting for tea time. Another 2 minutes. Yeah, I think you just reboot it. captured from an installation we've got operational. I've actually got a churn up in the booth. This shows the performance of the dam over a period of a single year, and you can see a very nice example of the cyclical behavior of this structure. The information can also be provided in a very intuitive graphical format. You can see here where we have icons representing the sensors. The color of the icon represents the state of the sensor. And if you click onto that icon, you can get information out of it in a tabular format or a graphic format with a chart. The important point I want to emphasize here is that the team that we've got based in India specializes in analyzing the dams which form part of the component project. So we come in, we look at the requirements of that dam, and we provide a report on the operating facilities that you would need to be able to monitor the performance of that dam using instrumentation. There's 2 examples of reports that we've done.